polynomial function can be graphed by knowing what the leading exponent is, as well as the first coefficient, or the leading coefficient. By definition, the polynomial function looks like a function with different terms. All have x's except for the last one, which is a constant. And depending upon what this term is, if it's positive or negative, that leading coefficient, and this term, if it's odd or even, you can graph it in different ways. The other idea is that you can have at most a certain number of zeros, and where this number, if it's 5, that means 5 would be the most number of zeros, and number of turning points like the max min points, and that would be n minus 1. This is a graph that shows the right end behavior and left end behavior, and this is it written formally in limit notation. Notice that your x is going to positive infinity for right end behavior and x is going to negative infinity for left end behavior. And the way to figure out what those limits are is to look at the positive or negative and odd or even. And so this is a nice graph that shows if the exponent, and that's that leading exponent, is odd or even, you're going to see certain directions of the graphs. Even like a square, you're going to have both going in the same direction, and if it's odd, it's going in opposite directions. Again, these are reflections over the x-axis. Similarly, you can see it this way, and again, it's talking about n being odd and a sub n being positive. Again, opposite directions, and then if your a is negative, it would go the other direction. Now, inside here, it's not really clear what's happening, but we're just going to focus on what is happening with the end behavior, what's happening as your x goes to positive infinity and as x goes to negative infinity. As the exponent is even, they look like this. Again, not really concerned too much about what is happening in the middle. We're looking at the end behavior. But what you can do is look at that y-intercept to give you just a little bit more information. I'd like to go through and do this problem. It says graph the function. Now, when you're looking at this function, I'm looking at this exponent, which is 5. That's odd. So that tells me that you're going to have one arrow up and the other one down. And then I'm looking at this negative sign, which means it's going to be the certain direction. So normally it rises to the right, and so now it's going to rise to the left. So I know it's going to come through something like this, and if I were to look at the y-intercept, that's going to be at -1, so I know there's a point here. So I know it goes through there, and I know it comes down, and so basically I know that that graph is going to look something like this without making a formalized table, and that's going to be -1. Now, the question is on this, what are the most number of turning points? Number of turning points is going to be n minus 1. N minus 1 is 5 minus 1, or 4. That's the maximum number of turning points in this graph. The most number of zeros, that's going to be equal to n, which is equal to 5. Right and left end behavior. Right and left end behavior, we're looking at as x goes to infinity. What's happening to my y? It's going to go down to negative infinity. So that means that this is going to be equal to a negative infinity. And the left hand behavior, x goes to negative infinity. What is happening to my f of x or my y? That's going to be going to positive infinity. So that's a lesson on polynomials, which look like this form or this form, and a way to figure out the most number of turning points, the most number of zeros, as well as what the general shape of that looks like.